Okay, so let's do the last 3 example problems. This is in log form. It's not helping me at all. So I'm going to convert to exponential. You start at your base. You loop around the equal sign. So you get 2, because your base always stays the same. The base in the log was 2, and the base of my exponential is going to stay 2. 2 to the 5th equals x minus 6. 2 to the 5th is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Add 6 to both sides, and you get 38 equals x. And it does say that you need to check your answers and make sure they're not extraneous. So log base 2 of 38 minus 6 equals 5. 2 to the 5th equals 32. That's a true statement, so this is my answer. It does work. Let's try another one. So on this one, I have 2 logarithms. And so before I can do anything, you have to use condensing and expanding rules to make sure that you have 1 log. So when you add your logs, you're really going to multiply. So I'm going to multiply my 5x times my x plus or x minus 1. And you only can do this because my base is the same. The base in both of these down here that's hiding is 10. When we write the word just log, the implied base is 10. So I have log of 5x times x minus 1 equals 2. So that's the same thing as log of 5x squared minus 5x. I distributed my 5x in equals 2. Again, I have that hiding base 10 here. I've condensed down to 1 logarithm, so now I can convert and do my little swoosh like this. And when I do that, I get 10 to the 2nd power equals 5x squared minus 5x. 10 to the 2nd is 100 equals 5x squared minus 5x. I'm now trying to solve a quadratic, and to solve quadratics, we need them to equal 0. So 0 equals 5x squared minus 5x minus 100. I moved my 100 over. I'm going to divide everything, both sides, by a 5. So I'm going to get 0 equals x squared minus x minus 20. You're going to then factor. So 0 equals x minus 5, x plus 4. You take each piece and set it equal to 0 using your 0 product property. So you get x equals 5 and x equals negative 4. So we have to make sure those are not extraneous. Let's check them. So I'm going to go back to my original and plug them in. So when I do that, I'm going to do the x equals 5 first. So when I do that, I get log of 25 because I plugged the 5 in for the x. So 5 times 5 is 25 plus log of 4 equals 2. When you condense these, you multiply. So 25 times 4 is 100. Remember, my hiding base here is 10. So when I do my swooshy, I get 10 squared is equal to 100, which is a true statement. That's good. We also have to check when x equals negative 4. So right off the bat, when I plug my negative 4 in, I get log of negative 20 plus log of negative 5. Here's my problem. You can't put this in a calculator because what this says is, in theory, log base of something, we'll call it a, of b equals x. Well, in my case, my b is negative. So what I'm really saying is log base a and then a negative number in here equals x. A to some power is never going to make something become negative because my a down here is a positive number. So if a is positive and I raise it to a power, I can never make it become negative, which means the argument right here of a logarithm can never be negative, which thus means that -4 is extraneous. So for my answer on this one, it's just x equals 5. The -4 is extraneous. Last one, log base 4 of x plus 12 plus log base 4 of x equals 3. Again, my bases are the same, so I can condense these by multiplying because I was adding. So I get x times x plus 12 equals 3. I'm going to make a swoosh and multiply out. So 4 to the third equals x times x plus 12. 4 to the third, 4 times 4 is 16, times 4 is 64. So 64 equals x squared plus 12x. Again, quadratic must equal 0 to solve. So x squared plus 12x minus 64. Make everything a little bit smaller, just move it a little bit. So to factor this, x plus 16, x minus 4. 16 minus 4 is my positive 12. 16 times -4 is my negative 64, which means x is going to equal negative 16 and x is going to equal positive 4 because I took each piece and set them equal to 0. And then again, you have to check for your extraneous solutions. So check. When I plug in negative 16 right off the bat, we should see that we have a problem because negative 16 plus 12 is going to be log base 4 of -4. And we can't have that. So this one is definitely extraneous. Let's check my 4. Log base 4, 4 plus 12 is 16, plus log base 4 of 4 equals 3. So 4 times 4, because I'm going to condense logs, is 64, so I get log base 4 of 64 equals 3. When you do a swoosh, 4 to the third does equal 64. So my x equals 4 is my only answer. My other one, my negative 16, was extraneous.